to polynomials. To begin with, we have some definitions we have to get under our belt. Okay, polynomial definition. A polynomial is an algebraic expression of the form an x to the n plus a sub n minus 1 to the x to the n minus 1 plus, and this continues all the way until you get down to an x term and a constant term. Okay, so an example of this would be something like 2x cubed plus 4x squared plus 5x minus 3. That could be pluses and minuses through there. The n power right there, in this case, is actually 3. 3 down to 2, that's n minus 1, down to 1, down to 0. Where all these exponents have to be non-negative. Okay, they must be either 0 or positive. Okay, each of these numbers as we went down, these are called the coefficients, so the 2, 4, 5, and negative 3. Those are all the coefficients in x. Each component of the sum is a term. So each of these parts is a term. And this number, the special one right down here, the minus 3, that is the constant term. Now the greatest exponent that you have is the degree of the polynomial, and the coefficient of that greatest exponent is the leading coefficient. So the degree of this one is 3, and the leading coefficient is 2. A polynomial consisting of only a constant term is called a constant polynomial, and the zero polynomial is a constant polynomial 0. Okay, and its degree is undefined. So let's do a few more examples on this next page. Identify the components of the given polynomial. So here, x to the 4th minus x squared plus x plus 5, the degree of that is going to be the highest exponent, in this case 4. The leading coefficient is going to be on this term, the coefficient, the constant in front of that, which in this case that is just a 1. The constant multiplied by it, pardon me. Leading coefficient is 1. And the constant term is this guy right here, the positive 5. Okay. All right, next we have 7x to the 5th plus 6x cubed minus 3x to the 8th plus 2. The degree is the highest exponent. In that case, this is an 8. So there's our leading term. Okay, so the degree is 8. The leading coefficient then is negative 3. And the constant term is the term without a variable, so that would be plus 2. Okay. Next polynomial we have is 17. It's a constant polynomial. And you know what? There aren't any x's, so the highest exponent is kind of a little hard to figure out. Kind of a little hard. It's not there. Okay, but if we do write this as x to the 0, 17 times x to the 0, because that's just 1, this is still the same polynomial, so the degree is actually 0. Okay, the leading coefficient then is actually the 17, and it's also the constant term. Last polynomial we have is the 0 polynomial. Okay, we were told earlier that its degree is undefined. So its degree is undefined, therefore there is no leading coefficient, but the constant term is 0. Alright, so like I said, those are the parts we're going to have to know. So next we're going to add and subtract some polynomials, as we see indicated. So we are combining like terms, looking for things that have the same variables and the same exponents. Now here, notice, these are just added. So really this is there's a 1 out in front of this parentheses, multiplied there. There's a 1. But if you multiply 1, distributing that doesn't change anything. So in this case, we can actually ignore the parentheses. So we can just combine negative 2x squared plus the 3x squared, which is 1x squared, or just x squared. Next we have plus 7x plus 2x, so that comes out to 9x. And then plus 9 minus 7, so we get plus 2. Okay, the difference comes when we have subtraction. So just look at this a little differently. 4x minus 13x should be negative 9x. Okay, and then 6 minus a negative. So I'm going to go ahead and do this. Change that. 6 plus a 9. Okay, so that's 15. So negative 9x plus 15. Part C, I'm going to go ahead and change this. So that's a negative 9x cubed plus 2x squared plus 10. So 9x cubed plus a negative 9x cubed, 0 pair, it's out. Negative 8x squared plus 2x squared should be negative 6x squared. 2x, actually that's the only x term, so plus 2x, and then plus 10. Okay, next we'll look at some multiplication. Multiply to find the following product. So here we multiply, distribute this, so we get negative 12r squared plus 30r. Okay, with part B, we have to make sure we multiply everything here by everything else. So we're going to take each of the two terms here, multiply each of these three over here. So I'm going to draw arrows just to keep up with it. Okay, that is 8m to the 5th minus 16m cubed. Let's see, plus 48m squared. And then we're going to take the 3. Okay, 3 times m to the 4th is plus 3m to the 4th minus 6m squared plus 18m. Okay, now it's customary to put the highest exponent first. When we put these together, we want to start with the highest exponent. So this will end up with just an 8m to the 5th. So that one's out. Let's see, we have the 4th power right here. So plus 3m to the 4th. Okay, let's see, cubed terms. We have this right here, minus 16m cubed. M squareds, we have two of them actually. We have 48m cubed, 48m squared minus 6m squared. So that should be plus 42m squared. And then last, plus 18m. Okay, final answer, 8m to the 5th plus 3m to the 4th minus 16m cubed plus 42m squared plus 18m. Okay, all right, parts C and D are both a special case of the distributive property. Sometimes you hear that called FOIL. I don't prefer that. Okay, we're just going to multiply everything by everything else. So 5k times 2k is 10k squared. Let's see, we've got 15k. Then here we have minus 2k minus 3. So combining like terms, 10k squared plus 13k minus 3. Okay, and I probably should box these in. Okay. Last one we have here, 7z times 2z should be 14z squared. Then we get plus 35z minus 6z minus 15. And our end result should be 14z squared. That's 29z minus 15. Okay, and those are all the terms we should have. All right, last problem we have is going to be a word problem. All right, a little bit of business terminology. A manufacturer of scientific calculators sells calculators for $12 each, wholesale. And he can produce a maximum of 150,000. That's kind of important. It's also important that we're selling them for $12 each. The variable cost of producing X thousand calculators, variable cost, is 6,995x minus 7.2x squared dollars, and the fixed costs for the manufacturing operation are $230,000. If X thousand calculators are manufactured and sold, find expressions for the revenue, the cost, and the profit. All right, so the revenue, okay, or that's going to be R of X, or only functions of X. Okay, now an important fact is that revenue is always the cost, the amount that you're selling it for, times X. Often you see this written as P times X, the price times the number that are sold. So the revenue in this case is 12 times X. We don't know how many are sold, so just X. All right, cost, that's going to be C of X. Now notice there were two sets of words in here, variable cost and fixed cost. Variable cost just means it changes the more that you sell. So that is this part right here. It has a variable X. That's all it is, the variable cost. So 6,995 minus 7.2x squared. Now then there's also fixed costs. We're going to add this in here. The fixed cost is $230,000. That just means this part does not change the more you sell. You automatically, it's like the cost for renting the building. Okay, the electricity here is variable. The cost for that could change. It will change. But the cost for just renting the space or something like that isn't going to change at all. Actually, a better example of the variable cost, you have the electricity charges. You've also got things like how much you're paying your employees, because the more that you sell, the more employees you're going to have, and that cost is going to go up. Okay, so there's our revenue and our cost. Now our profit, P of X, is always revenue minus cost. So it's how much you have made minus how much you paid already. So it's profit is how much is left over, how much above that you've gone. Right, so we're going to find the profit function by taking our revenue function, 12x, and subtracting the cost function. So 12x minus 6995x minus 7.2 x squared plus 230,000. So if we combine like terms, our final answer, okay, and I'm going to put the highest exponent first, is 7.2 x squared. 7.2 x squared minus 6,983 x minus 230,000. And there is our profit function. So we have our revenue function, our final cost function with the two variable and fixed costs included, and our profit function. So that brings us to the end of this section.